Hello everyone. So here we can explore the idea of a limit. So what is a limit? Well, suppose we have a function like this. Suppose we have a function of x over 3 plus 1. Okay, so for this function, so for every x value that we have, so for example, at x equaling to 4, what is the value of the function? Meaning, what is the value of y? Well, at x equaling to 4, we have, so let's make it 4. At x equaling to 4, we have y equaling to 2.333, okay? At x equaling to 2, for example, we have the y to equal to 1.667, okay? We have a corresponding y for any x that we choose, okay? So for example, right here, at x equaling to -3, we have y equaling to 0, okay? So as you can see, for example, if I decrease my x's, okay, my y's also decrease, okay? And if I increase my x's, my y's also increase, okay? However, for a function like x to the 2 minus 1 over x minus 1, okay? Let's see if that's the case. Let's see if I have a corresponding y for every x. So for example, at x equaling to 4, I have a y value equaling to 5. If I decrease my x's, so right here, for example, at x equaling to 3.03, I have a y value of 4.03. At x equaling to 2.1, I have a y value of 3.1. At x equaling to 1.19, I have a y value of 2.19, okay? At x equaling to, let's say, 1, well, I don't have a y value right here. At x equaling to 1, I do not have any y value, okay? Because imagine it, so if I evaluate 1 into the function, so it will be 1 squared minus 1, which is 1 minus 1, which is 0, over 1 minus 1. It will give you 0 over 0, so it will give you an undefined thing, okay? So at x equaling to 1, I don't have any y value. The function is undefined, okay? So maybe what we need is not the value of the function at x equaling to 1, since the value of the function is undefined. However, the value of the function as we approach 1, okay? So if I have, right here, we have x equaling to 1. So let's zoom in a little bit. And let's change this to red and to this. So at x equaling to 1, I don't have any y value, okay? But let's see, if I approach x from right and from left, what does the value of y approaches to? Okay, so if I approach x from this side, okay, meaning if I start, for example, at 2, at x equaling to 2, okay, and I approach 1, so I become 1.965, 1.785, 1.6, okay? Watch the y values. So right here, the y value is 2.6. And then it becomes 2.4, and then it becomes 2.3, and then it becomes 2.2, 2.1, 2.09. It seems like the closer my x gets from right-hand side to 1, okay, my y values get closer and closer to 2. So if we zoom in more, okay, so right here my x value is very, very close to 1. My y value is also close to 2, okay? If we get like this close, as you can see, my x value is very, very, very close to 1. My y value is very, very close to 2. At 1, it is undefined. However, as I get closer and closer to 1, as my x value gets closer and closer to 1, my y value gets closer and closer to 2. Okay, that is if I approach the x value from right hand side. But if I approach it from the left hand side, well, as I get closer and closer to 1, so right here my x value equals to 0.9644. As I get closer and closer to 1, so if it becomes 0.9999, okay, my y value gets closer and closer to 2. Okay, so in situations like that, when I don't have a y value for a particular x, okay, maybe I don't want that. Maybe I just need to know the behavior of the function as I approach that particular x value. Okay? And mathematicians, for these situations, created the idea of a limit. Okay? So the limit is the behavior of your function around a particular x value. Okay, so for this function right here, for example, x to the 2 minus 1 over x minus 1, we know that at x equaling to 1, the function is not defined. Okay, however, we know that as we approach x equaling to 1 from right hand side and from left hand side, the function goes toward 2. Okay, as I approach x from the right hand side and from the left hand side, the y value of this function gets closer and closer to 2. Okay, so this gives us an idea of how the function behaves. We may not know what is the value of the function at x equaling to 1, but we know that as we get closer and closer to 1 from right hand side and from the left hand side, the function approaches 2. Okay, that is basically the idea of a limit. So let's explore this in more detail on the drawing boards. So here is our function. This is f of x equaling to x to the 2 minus 1 over x minus 1. Okay, so the graph, or this blue graph right here, is the graph of f of x equaling x to the 2 minus 1 over x minus 1. We know that, so this is x equaling to 1. Okay, we know that at x equaling to 1, we do not have any y value. Okay, however, in the vicinity around 1, we are interested in the value of the function. Okay, so as I approach x like that from the right hand side, the y values get closer and closer to 2 from up. Okay, so if you are a person right here and you are on the graph of f of x equaling x to the 2 minus 1 over x minus 1, and in your hand you are holding the x values and the y values. This is the x values and this is the y values. Okay, so as you slide down, or as you walk on the graph of f of x equaling x to the 2 minus 1 over x minus 1, you go like that. Okay, what happens to your x values? Well, your x values get closer and closer to 1. Okay, so probably where you start, your x value is 2. As you walk, okay, like that, your x values decrease. They go toward 1. Okay, what happens to your y values? Well, your y values, okay, so for example right here, your y value could be 2.2. As you walk, okay, your y value decreases. It becomes 2.15, 2.14, 2.13. It gets closer and closer to 2. Okay, so at the exact moment such that you reach this point, when you are on x equaling to 1, you will not have any y value. Okay, that's why we are interested in the values of the y when you get closer and closer to 1. The same goes if you start right here and you are holding the x and the y values. If you go up like that, your x values, they are small and they get bigger and bigger. They go toward 1. Your y values, they are small. They go bigger and bigger. They go toward 2. Okay? So when we talk about limit, we are talking about what happens, or we are talking about the behavior of your function around a particular x value. For this function, when we get closer and closer to 1, to x equaling to 1, our y values get closer and closer to 2. That's why the limit of this function is 2. Okay, so how do we denote this? What is the notation for a limit? Well, we say that the limit of f of x, so for example of this particular f of x, as x approaches 1 equals to 2. So for f of x, as I approach my x equaling to 1, my y values get closer and closer to 2. Always, this value that you have that equals your limit, it will be a y value. Okay, so as I get closer and closer to x equaling to 1, my y values get closer and closer to 2. they go like that. They get closer and closer to this point, which is 2, which is y equaling to 2. So the limit of f of x as x approaches 1 equals to 2. Okay? We have condition for a limit to exist. So here, for example, as I approach x from the right and from the left, my y values get closer and closer to 2. But if you approach your x value from the right, you get a particular value. Suppose you get a, and then when you approach x from the left, you get a particular value. Suppose it is b. If these two values are not equal, then you don't have a limit. Okay? So for example, if I have a function like that, I have this function, okay? Or let's make it different. Let's make it like that. Okay, this function, g of x. So does this function has a limit at x equaling to 1? Okay, well, let's see. If I approach x equaling to 1, so suppose you are this person walking on the graph and you are holding the x values and the y values. So as I get closer and closer to 1, what happens to the y values? Well, the y values get closer and closer to this. This is, so if this is 1, this is 0.8, this is 0.6. So as I walk on the graph, okay, such that my x gets closer and closer to 1, my y values get closer and closer to 0.6. That is if I approach x from the right hand side. That is if I approach x equaling to 1 from the right hand side. What if I approach it from the left hand side? What if I approach it like that? Well, if you are right here and you approach x equaling to 1 and you are holding the x values and the y values, your x values get closer and closer to 1. However, your y values get closer and closer to this point. This point has a y value of around 0.65. 0.65. Okay? So 0.65 does not equal to 0.6. So as you approach x equaling to 1 from the right hand side, your y values tend to go toward a particular value, which is 0.6. As you approach it from the left, your y values tend to go toward 0.65. These two values are not the same. Therefore, this function g of x at x equaling to 1 does not have a limit. Okay, since the y values do not go toward the same value when I approach this particular x from the right and from the left. However, for f of x, since when I approach x equaling to 1 from the right and from the left, I get the same y value, or my function approaches the same y value, therefore f of x equaling to x to the 2 minus 1 over x minus 1 has a limit, and the limit of it equals to 2. Okay? That is basically the idea of a limit, and that is the condition of existence of a limit. The limit of the right hand side has to equal to the limit of the left hand side. And the way we denote this, we say that for this particular function, for example, we say that the limit of f of x as x approaches 1 from the right hand side equals to 2. And the limit of f of x as x approaches 1 from the left hand side equals to 2. If these two values are equal, then the function has a limit. If they are not, the function does not have a limit, just like we saw it for g of x. Okay? So let me repeat it again. It's very, very important, and it's very, very simple. What is the idea of a limit? Well, the idea of a limit is the behavior of a function around a particular x value. Particularly, what does the function go toward or approaches as I approach a particular x value? Okay, that is a limit. And a function has a limit at a particular x value if the right hand side limit equals to the left hand side limit. Meaning when you approach your particular x from the right, your y goes toward the same value as you approach your x from the left. And again and again, we are not interested at the value of the function at that particular x value. Okay, so here we are not interested at what the function gives us at x equaling to 1. We are interested at what the function approaches as we go toward x equaling to 1. So for example, if you have a function like that, okay, as you can see at x equaling to 1, the function is defined. At x equaling to 1, your y value equals to 1. Okay, however, if they ask you what is the limit of this function, well, if you are right here and you are walking on the graph of this function, as you approach 1, so again you are holding the x values and the y values, as your x values get closer and closer to 1, your y values get closer and closer to 2. Okay, and if you are right here, okay, and you are going like that, your y values also go toward 2. So the limit of this function f of x as x approaches 1 equals to 2, even though at x equaling to 1, y equals to 1. Okay, right here. We are not interested in that. We are interested as I get closer to 1, not at 1, as I get closer to 1. Okay, I might have said that a lot, but I just want you to be careful and I want you to understand the idea of a limit. For here, as I go toward 1, my y value go toward 2. As I go toward 1 from the left hand side, my y value go toward 2. Therefore, the limit of this function equals to 2. The same goes for any point on this function. So for example, right here, what is the limit of the function at x approach to 0? Well, as I approach x equaling to 0 from the left hand side, my y values go toward 1. As I approach x equaling to 0 from the left hand side, my y values go toward 1. So the limit of, let's say we call it g of x, as x approaches 0 equals to 1. Okay, so let's check out a couple of examples on limits.